All right, so we're going to pick up where we left off. We're at the very end of 6.3, looking at the multi-step transformations. We had gone through the order that we always have to follow, and we had done example 1. Okay, so let's take a look at example 2, but let's just add something to it. Okay, so this will be a multi-step. And this time it has, how many transformations in it? Yep. 3. Yep, there's 3. Because there's 3, the order is going to be important. Let's start with the harder one, which is the x. I'm going to put my original x's on the outside. I'm also going to put my original y's on the outside. And then I'll put my final answers in that table that has the box. Okay. What do we have to do to all the original x values in this one? Yeah?
You divide by 2?
Yep, we divide them all by 2, which is the same as taking half of them. So take half of all the x values. So that's going to give you 0. What's half of pi over 2? Yep. Pi over 4. And then half of pi. Just pi over 2. What's half of 3 pi over 2? Yep. 3 pi over 4. And half of 2 pi. 1 pi. Okay, so those are the harder ones. Those are the x's. And now we got to change all the y's. We have to times. There's a times 3 involved, and there's a minus 4. But we got to make sure we do the correct one first. Which one do we do first? So you have to know what the times 3 is doing and what the minus 4 is doing. Yeah. Right. 3 is multiplying by 3 is a stretch. Minusing 4 is a shift down. So you're going to multiply by 3 first, then subtract 4. So think of it like this. Okay. So the first one, that's going to give you 3 minus 4. Second one, 0 minus 4. How about the third one? Negative 7. Yep. And the fourth one, that's going to be negative 4. And the last one, negative 1. So that's a multi-step transformation that had 3 steps. We changed the period length, did a vertical stretch, and we shifted it down 4. Okay, so for the sketch, x's are pretty straightforward. We're just going to label each tick mark using our labels in the table. So pi over 4, pi over 2, 3 pi over 4, and pi. And those are equally spaced. If you did it in degrees, that's 0, 45, 90, 135, 180. They're spaced at 45s. Okay, but for the y's, you know what I'm going to do? I'm going to go like this. Just put that there. I need more graph. So let's go like that. I guess that'll kind of work. All right, I need to go down though. So I need to go as low as negative 7. All right, so ignore the bold lines. I'm gonna put my own numbers on this. Let's make this 0, negative 2, 4, 6, and I only need to go down to negative 7, so that's plenty. Okay, so we got 0, negative 1. Let me zoom out so I can see it. Oops. Okay, 0, negative 1 would be, let's see, so 0, -1. Pi over 4, we are at -4. So pi over 4, -4. Again, ignore the bold lines. I renumbered everything. Pi over 2, I'm at -7. So pi over 2, about right there. 3 pi over 4, I'm at -4. So 3 pi over 4. I'll fix my labels. I know they don't line up. I'll take care of that. And 2 pi, I'm at -1. About right there. Okay. And let me just line my labels up. Oh, that's better. Okay. So there's our sketch, and then I just draw it in. Okay. So any questions how we got the sketch or the table? Okay. So now, as far as graphing by hand, I think we're done. Okay, so we've done all the different kinds of graphs we're going to do by hand, single step and multi-step. Now we're going to do some on the calculator. It says to find a complete graph of 4 times 3 sine x, and then find the domain, range, period, and amplitude. Okay, so let's put this in. When we graph it, we want to make sure that we are in radians. Okay, so if you are not in radians, you press mode, and then you have to go down to the 4th line where it says radians and degrees, and click on radians. Okay, go to y equals, I already have it typed in, 4 sine 3x. Radians. If they don't tell us a certain window to use, I do zoom 7. So zoom 7 is kind of like we used to do zoom 6. Well, when we do trig, we use zoom 7. It's a little bit better window for looking at trig functions. Okay. So we'll press zoom 7. And if that's not a good window, we can adjust it. It's okay. I don't like when the top and the bottom is right on the edge of the screen, so I'm actually going to set my y min and max to be like -6 to 6. Just so I know it doesn't go any higher than what I think it's doing. Okay, we're seeing a lot of cycles. That's fine. We can look at as many cycles as we want, whatever we need to answer this question. Okay, let's start with the domain. The domain is how far it goes left and right. Okay, so what would the domain be for that graph? All real numbers, yeah. Every sine and cosine function has a domain of all real numbers. You can plug in any number you want for x. The graph goes forever left and right, and it is continuous. Okay, there's no breaks or holes or asymptotes. So all real numbers. Now, the range is not all real numbers. There is a limit to how high and low it goes. What's the lowest that the graph goes, and it does actually hit this number? Yep.
+4 and -4.
So the lowest is -4, and the highest is +4. And because it hits them, what symbol should we use when we write our interval? Yep. We're not writing an inequality. We're writing an interval.
Oh, the bracket.
Bracket. Yep. So there's your domain. There's your range. What's the amplitude of that graph? Yep, 4. It's the absolute value of the number in front. As a picture, it's the distance from the midline to the peak, or from the midline all the way down to the bottom. But either way, that's 4 units. And the period. What's the formula that I think we learned yesterday or 2 days ago for finding the period? And this formula is for sine and cosine. Yep.
2 pi divided by b.
2 pi divided by, and what is b in this case? What is it? 3. And that's everything they want. Okay, so we found a complete graph. We showed a lot more cycles than was necessary, but it's fine. And we got domain, range, amplitude, and period. Any questions on finding those 4 things? Okay. Let's try this one. Same idea. Find a complete graph, and then find domain, range, period, amplitude. Well, you should be able to tell me the domain before we even sketch it. Yeah?
All real numbers.
Yeah, every sine and cosine function is all real numbers. They're all waves that go forever, left and right, and they're connected. So domain is all real numbers. Okay, range. Anyone think they could tell me what the range would be before we graph it? Yeah?
In brackets, -3 and 3.
Yeah. It would go from -3 to 3 because normally it goes -1 to 1, but you have tripled the height. So now it's -3 to 3. Actually, I think we can do all this without a picture. Amplitude? What's the amplitude? Yeah. Absolute value of the number in front. And period. What's the period of this? Yeah.
Is it 2 pi over -1?
I like the 2 pi, but no, it's not over -1. Yep.
Is it 2 pi over 3?
Well, what's the formula again? 2 pi over
2 pi
b.
over b.
What's b?
1.
B's not 3.
-1.
That's c. No, that's a. A is -1.
Oh, sorry, there's only 2.
Positive 1. That's good.
Just 2 pi.
So just 2 pi.
So it's just 2 pi. This graph does not have a change in period. That shifting left or right, that did nothing to all of these answers. I could make that a -1 or a -600. It wouldn't change the domain, range, amplitude, or period. Doesn't affect any of them. Okay, and then just make sure we practice our sketch.
Can you do all of them without the graph? It's
Um,
gonna get more complicated.
A lot of times you can do it without the graph, for sine and cosine, yes. Other trig functions can be a little harder. So 3 sine x minus 1.
Will there
Zoom.
be other trig functions on the test or just sine?
Possibly, I'm not sure. I'll let you know within the next 60 minutes. So there's your sketch, and it confirms everything we said. Highest is 3, lowest is -3, amplitude is 3, right there. Period is 2 pi, and it goes forever left and right. Any questions on that one? All right, so the last thing is solving trig equations. So when we solve trig equations, there's a couple ways you can do it. We're going to start out by doing it graphically. And then later on, we'll learn how to do it without a graph. So we're going to try to graph this, and we're going to graph that. And then we're going to see where they're equal. What do you think that means we're going to calculate on the picture? Yep.
Inequalities.
We are going to do an inequality in a little bit. We're going to change the equal sign to an inequality and do one like that. But this one is an equation, so we don't have to worry about anything with an inequality. but it is something we've done before. Yeah?
Are we gonna put both in front of intercept?
We're gonna put, so go ahead, tell me what to do.
I'll put one in sine x and y2 and 0.4 in y. Sine x and y1, 0.4
Okay.
in sine in y2.
We put that in Y2. And then what kind of zoom should we do if they didn't tell us?
6. Oh,
7 if they don't tell us, but they did tell us. What did they specifically tell me to set my x min and x max to? They told me to only look between 0 and 2 pi. Okay, so that's what they're telling me right there. So we don't want to, we could do zoom 7 for a starting point, but you'd have to fix it and set it like this. Now, what's the highest and the lowest that sine is going to go? Yeah.
1 and negative
1 and negative 1, and right now I have it set 4 to negative 4. That's a little extra, but it's okay. We can leave it like that. Okay, so we hit graph. Since we're setting it 0 to 2 pi, we're going to see exactly 1 cycle. There's my line at 0.4. And what do I have to do now? Yep.
Find the intersections.
Great. We have to find where they intersect. So I'll do this one first just because I'm closer. Okay, so one answer you get is about 2.73. And the other answer you get is about 0.41. That's it. That's how you find your 2 answers. Okay. If they wanted you to do this same problem in degrees, we could. They don't want degrees because I can see 0 to 2 pi. That's radians. But if they wanted degrees, what would I be between? It wouldn't be 0 to 2 pi. It would be what? Yep.
0 to 360.
It would be 0 to 360. And then I would change my mode. I already did. Change it to degrees. It's not going to look any different. The graph is going to look exactly the same because I changed my window and I changed the mode. But when I do an intersect this time, instead of getting these decimals of 0.41 and 2.73, I'm going to get answers in degrees. I'm not going to do both of them. I'll just do the one on the right. So in degrees, 2.73 is 156.4 degrees. And you know the mode you're in because it's always right at the top. So the top picture is radians. The bottom picture is degrees. Okay, it looks a little bolder on the axis. That's just because of the spacing of the tick marks. That's not important. Okay. Any questions on the first one? All right, let's try another one. So again, they're asking us to solve an equation. And I want to make sure I set it up like I did the first one, 0 to 2 pi. Notice they don't include both 0 and 2 pi. They only include one of them because when you look at your screen, this point right here is exactly the same as that point right there. Once you've gone through one full cycle, you're about to repeat what you already had. So if you include the left edge of your screen, you shouldn't include the very right edge. 0 is exactly the same as 360. That's why we don't include both. So in this problem, they're specifically saying include the left edge of the screen, but don't include the right edge. Okay? Because the right edge is a repeat. It's the left edge starting over in the next cycle. Okay, what would I put in Y1 this time? Yeah?
2 cosine 1 half x
Yep, and just because it's easier for me to avoid the fraction, I'm going to do cosine 0.5x, same as a half. If you had to do the fraction, you can.
Would you have to put parentheses inside the parentheses?
Yeah, yeah, you need like 1/2 in parentheses, yeah. So you'd have another set. And this time we're going to put 1.5 in y2. They said between 0 and 2 pi. I'm already set from the last, oh no, I'm not, I changed it. So I got to change it back to 0 to 2 pi. And I got to change my mode back to what? Yeah, I got to go back to radians. Now I'm all set. So now this 1/2 causes the graph to stretch. Because the graph has been stretched out, it doesn't have a chance to cross it twice. The blue one is too long for that to happen in that window that they gave me. So this is only one answer. And because it's only one answer, I can just hit enter and it'll find it. Okay, so 1.45 radians. Any question on that one? These are kind of all the same. You just put 1 in y1, you put 1 in y2, and then you see where they cross. This is exactly the same problem again.
How would you write the answer? Just like the coordinates?
How would you write the answer? You write it exactly like that. X equals 1.45. Yep. You don't have to write it as a coordinate because I already know what the y value is. That's the y value, 1.5, because that's where the red line was. Same thing here. The y value was 0.4. I just need the x value. All right, let's try this one. 2 cosine x is greater than negative 1.3. Okay, what's going to go in y1? 2 cosine x, and then in y2?
Would it still be negative 1.3?
Yeah, it's still negative 1.3. You're going to do it exactly the same way you do it if it was an equals. Except window is already 0 to 2 pi, so I have that all set. Hit graph. Except the answer this time isn't going to be x equals a number. Okay? It's going to be a section of numbers because it's an inequality. Is there anywhere that the cosine graph goes above negative 1.3? How many different sections? 2. It's above negative 1.3 from here to here and from there to there. There's 2 sections. So now we have to describe where do these green sections start and stop. Each one of them. Section 1 and section 2. Well, let's do section 1. Where does section 1 start? Yep. Remember, nothing exists outside this window because they told me to only examine between 0 and 2 pi.
So 0 then?
Right. 0 is where section 1 starts. Can we include the 0 or not include the 0?
Yeah.
Why can we include it?
Because it's above the.
Yep.
Because it says 0 is less than or equal to?
Yes. It says when you are writing your answers for x's, you can equal 0 if that was part of your answer, and it is. So yes, we can equal 0. And we're going to go right up to the end of interval 1. Now, when we get to the end of interval 1, can we equal the red line? Or do I have to be above the red line? I have to be above it. So that means I cannot include the very end of that green section 1. If I'm not going to include it, what symbol should I use? parenthesis. We'll figure out what that number is in a second. But now we have another interval we have to describe. When I have to describe two intervals, what symbol do I put between them? Yeah? The U, yeah. This means or. So where is 2 cosine x greater than negative 1.3? It's going to be here, which we need to finish, or it's going to be over here. So let's start with interval 2. Can I include where interval 2 starts? No. We can't include it because it says it has to be above the red line. Because I can't include it, what symbol is going to start interval 2? Yeah? Parenthesis. I don't know the number yet. I have to find the intersection point. But now, how about where does interval 2 stop? It stops at the right edge of the screen. It stops right there. That right edge of the screen is at 2 pi. Can we include or not include 2 pi in our answer? Right, not include. It says right here, you cannot include 2 pi. So I can do all of that without actually calculating the intersect. Now we need the intersect. So we have to figure out where interval 1 stops, which is second calc intersect. 2.28. And we have to figure out where interval 2 starts. So second calc intersect. So you still have to find the intersect, just like you're doing an equation. Your answer is just written a little different. And we've done intervals before. 4.00. If they wanted to know where the cosine x was less than the red line, well, then you would be describing the section that's underneath, and it would only be one section where it's under. But there are 2 sections where it's above. Okay, any questions on that? So that's solving trig equations and inequalities graphically. Any questions? Okay. All right, so the last thing we're going to take a little bit of a look at, it's kind of a reduced version of 6.4, is basically all the other functions. Okay? Everything that we just did Monday, Tuesday, and Wednesday, but we don't go into as much depth. We also don't do any graphing by hand. Okay? If we have to graph tangent or any of the other functions, I'm going to show you what they look like, but we're going to do them on the calculator. So what do sine and cosine look like when we graph them? Yeah? And what's that?
I don't know the name.
Waves.
Yeah, like a wave.
Oh, okay.
It's a sinusoidal wave. That's the pattern of it.
Too hard.
All the other trig functions are not waves. Okay, they look different. So let me draw a picture of tangent, and then I'll copy it over here bigger. You might look at the board and already see I wrote something down that tangent is going to have. It's going to have asymptotes. So there's a pattern to tangent, and it does repeat itself over and over, like sine and cosine, but they're not connected. Okay? This is what the graph of tangent looks like. So there's breaks in the graph. Just draw in where they are. There. 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 There's breaks, and I could keep drawing them in. And what the graph looks like is it goes right through the middle of where the 2 breaks are. It goes right down through the middle, like this. That's what the graph of tangent looks like. And if you take that one curve and copy and paste it, you'll get the next section of tangent. Okay? And you can keep copying and pasting that section as many times as you want to get all the sections. Now, what's pi over 2 in degrees? Yeah, 90. If I put my calculator in degrees and I try to take the tangent of 90, what do you think is going to happen?
Syntax error.
Syntax would mean I typed something in wrong. I typed everything in properly. So it won't be a syntax error. Have another guess what'll happen? Well, what's happening at 90 in the graph for pi over 2? Yeah?
It's approaching it, but never like reaching it.
Okay, it's approaching, but it's never actually reaching pi over 2. So what do you think that means if I actually try to find the value at pi over 2? What's that?
There will be none.
There wouldn't be one, yeah. Gives me an error. And it says that 90 is not, or pi over 2, if I had done that one, is not in the domain. Every one of these vertical asymptotes, that's 270, 3 pi over 2. If I try to find the tangent of 270, you can't do that. There are values that are not included in the tangent function. And the ones that I have circled, these are the ones that you can't include. It's every other multiple of 90. 90 doesn't work. 180 is okay. That's pi. But 270 doesn't work. 360 is okay. But then 450 is not. So every other multiple of pi does not work. Starting with 90, as 90 does not work. So 0 would be okay, but negative pi over 2 would not. Negative pi is okay, but negative 3 pi over 2 is not. Okay, so that's what the graph of tangent looks like. Now, when we look at our asymptotes, if I label them, asymptote 1, 2, and 3. And then let's call this section inside here section 1, section 2. We have to understand how many asymptotes there are per section. There's only one per section. Okay? It's kind of like if you have two armrests on each side of you. Right? If everybody's sitting next to each other, you all have two armrests. Well, if you want to split them equally, you can't take both. Right? Because then if everybody tried to take both, that wouldn't work. So section 1 has like an armrest on the left and an armrest on the right. You can't say that this asymptote right here, you can't say both of them belong to section 1. Because then, how would you say both of them belong to section 2? You just said this belongs to section 1. So the idea is there is only one asymptote per cycle. It doesn't matter how you think of it. I usually just say, well, the left one belongs to section 1. Asymptote 2 belongs to section 2. Asymptote 3 would belong to section 3, which would be over there. Does that make sense that there's not 2 per section and only 1? Just think of like the armrest idea. Now, let's look at the graph of cotangent. What's the connection between tangent and cotangent? Yeah?
Cotangent is the inverse of tangent.
Not the inverse of it. There's another word though, but yeah.
Is it the reciprocal?
It's the reciprocal. It's the tangent flipped. So when you graph cotangent, it looks very similar. This is cotangent. What's the difference?
Going the other way.
Yeah, it curves the other way. Okay, tangent always kind of curves up to the right. Cotangent curves down to the right. What else do you notice about the asymptotes?
The other ones.
Yeah, they're all the other ones. So wherever it crossed the x-axis before in tangent, that's now an asymptote in cotangent. Everything flipped. Wherever you had an asymptote, like at pi over 2, in cotangent, that's where it crosses. There's no asymptote. So from tangent to cotangent, all the asymptotes and the zeros switch. They all switch places. Okay, I've written out some of the asymptotes for each. In a minute, I'm going to put this information that I just circled, I'm going to put it in a table. So you're going to have it like this. Okay, this is going to be a summary of the asymptotes. Because you don't really need to know all of them. Right? All you need to know is one of them, and then know how often it keeps repeating. Well, let's look at this again. We said pi over 2 was how many degrees? 90. What's 3 pi over 2? Yep, that's 270. So as you travel from here over to here, you are going through one full cycle of tangent. This, what's between these two blue lines, that is a full cycle right there. How far is it from 90 to 270?
180.
180. So that is a difference with tangent and cotangent. To travel one full cycle, you don't have to travel 360. You only have to travel 180. And tangent and cotangent are the only two that have that. Every other function we studied, sine, cosine, and the secant and the cosecant, you have to travel 360 to get through a full cycle. And I think I write that down. I'm going to write that down in a minute. So the period length of tangent and cotangent is 180 degrees, or if you want to say it in radians, pi. Okay. And we are going to look at secant and cosecant. So I want you to leave 4 rows in your table. But so far, I'm not going to show you secant and cosecant yet because we haven't done it. So what I'm showing you in this table is the first non-negative asymptote for each function. For tangent, the first non-negative asymptote you get to is pi over 2. And then the next one after that, for cotangent, is 0. And we'll get to the new column in a minute. I haven't talked about that yet. And what did we say the period of tangent and cotangent are? Pi. So if this is where your asymptotes start at pi over 2, if you add pi to that, you'll get the next one. And if you add pi again, you'll get the next one after that. Every time you add the period to the one you started with, you'll get a new asymptote. Question on that? So if your first asymptote for cotangent is right here at 0, and the period length is pi, what would be the next asymptote after 0 for cotangent? Yep, pi. What would be the next one after that? Yeah.
2 pi.
2 pi. So that's 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. If you just keep adding the period, you'll just keep getting more and more asymptotes. This is the only one that you have to really remember, though. If you can remember where the asymptote starts, then you can find any one that you want earlier or later in the cycle. All right, so I'm not going to go through transformations for tangent because they are exactly the same as everything that we did with sine and cosine. Same letters, same everything. But there's a chart. If you don't remember what letter does what, that will explain what everything does. Is there any question, because again, I don't plan on really going through an example, but is there any question on what the A, the B, the C, or the D do? Well, I guess a couple things I'll ask you. If it's plus A, which way does that move the graph? Left. Moves it left. And minus A? To the right. Yep. That's exactly the same. If D is a positive number, that would shift the graph which way?
Up.
Up. And if D was negative, down. Yep. Okay. So what was the formula we used to find the period of sine and cosine? Yeah?
2 pi over b.
Okay. So I'm just going to change how you said that a little bit. That is correct. We did the original period over b. Let's think about tangent. What's the original period for tangent? Yep. Pi. Period of tangent is pi. So when we want to find the period of a tangent function, you can't use this. That's for sine and cosine. What do you think the formula would be for the tangent function to find the period? Yep.
Pi over b.
Yep. Pi over b. Tangent and cotangent are the only two that use pi over b. All the other ones use 2 pi over b. Any question on the formula for the period of tangent or cotangent? Just remember, it's a pi over b. It's not a 2 pi over b. If you use 2 pi over b, you're going to get double the answer you want to. Okay, let's look at this one. It says find the period of tangent 2x. Okay. First, can somebody tell me what's the formula to find the period of tangent or cotangent? Same formula.
Pi over b.
Pi over b. And in our case, what is b? 2. So the period is pi over 2. So that's the first part. Now the second part says to graph that on the calculator and show 3 full cycles. Well, that's the length of 1 cycle. So what would be the length of 3 cycles? Yeah. 3 pi over 2. Why'd they pick 3 cycles? I don't know, just pick 3 cycles. So what I'm going to do on my window, the easiest way to show 3 cycles is to start at 0 and go to 3 pi over 2. Okay? By setting it from 0 to 3 pi over 2, that will show me exactly 3 cycles. So I always just go 0 to whatever number I need. I want to make sure that I am in radians, but everything else looks fine. I can set my window and then go change it to radians after. That's fine. If I go back to the window, it won't change anything. It's still set to exactly what I put. And we just need to put in tan 2x. So if we found the period correctly, we should see exactly 3 cycles. Well, that's a half a cycle. That's a whole cycle. That's a whole cycle. And that's a half cycle. So did we show 3 cycles there? You think? Yeah? Yeah, we broke one into halves. That's okay though. We've got a whole, half. So that's 3 cycles. Okay. If you weren't able to find this period correctly, you wouldn't know what to set your window at to see 3 cycles. Any question how we got the period or the graph of 3 cycles? Okay, so this one says, looking at the graphs below, I want you to identify which graph here is the 2 tangent x and which one is 5 tangent x. So you have to know what the 2 and the 5 are doing. So anybody think they know which one is which? Yeah?
I think it's 2 and 5.
You think this one on the left is the
2.
the 2?
Yep.
How come?
Don't ask that. Just know that I think it's that.
You think it's that, okay.
I don't know, if you're multiplying the pi, then it would get bigger, and that one looks like it has larger swirly whirly parts.
Okay, yep, kid.
I mean, she said it in a better way than me, I guess. Yeah, it just looks, the one on the right, 5's a bigger number. It looks,
So what is the 5 doing?
Multiplying.
Like what kind of transformation?
Stretch.
It's a stretch.
Okay, you're
So-
good at it.
Here's your graph. If I take something like that and I stretch it, take something like that and I stretch it vertically,
Whoa.
it starts to look like that. What happened to the curve?
It starts like stretching out.
Right, the more that I stretch it,
It says no.
the less sharp the curve is becoming.
So 5 is the one on the left and 2
Yeah.
is the one on the right.
Right. The one on the left is 5 tangent x. So imagine like this was like a piece of metal and it had that curve in it. And you start to stretch it. Okay? What's going to happen as you stretch it? It's going to start to straighten out. The curve doesn't quite go away, but it does start to become less. Okay? So that's 5 tangent x. This is 2 tangent x. Any question why the left one is the 5? It's more stretched, so it looks straighter. And if I started to compress it, then the curve would start to get more pronounced. Might look more like this, because now it's been squished. All right. So let's look at the last 2 graphs, which are secant and cosecant. That is secant. One cycle of secant is what I'm going to draw in red. One U shape one N shape. That's a full cycle.
Oh,
Each U shape and N shape keeps repeating forever.
can I watch?
So if I draw like a box, if you want to see like exactly what one cycle is, where I have the purple box, that is one cycle of secant. And what's the connection between secant and cosecant?
So,
What's that?
are we asking?
What's the connection between these two?
Oh,
This one is 1 over what?
oh, yeah, you lost me. Pi? No? Okay. Not pi?
Like how do you do secant on the calculator because you don't have a button for it?
1 over secant.
Well, you don't have a button for
Is
it.
it 1 over sine? No, never mind.
No, not 1 over sine.
Can I ask you?
What is it just for Hager?
Yep.
Are you trying to find cosecant?
I'm just asking what secant is first. Like if you had to, if I said to you, what's the secant of 13? How are you going to put that in on the calculator? Because you don't, there's no button for secant on there. Not for secant.
River's not here.
Yep.
1 over cosine.
Secant is 1 over cosine.
Oh my god. Oh.
It's the cosine flipped. If you remember when we did unit circle trig, secant and cosine were in the same row. How about cosecant? What's that one? What would it be? Sine flipped. Yeah. So if you think about secant and cosecant, one of them is cosine flipped. The other one is sine flipped. When you graph sine and cosine together, how do they compare to each other? Yeah?
They start with an R, right?
What's that?
They start with an R.
Well, I'm asking you to kind of describe the picture.
Oh.
Like if you graph sine and you graph cosine together.
I don't know, maybe it's like sideways.
They're both waves.
They're both waves, but they are a little different. What's the difference?
Isn't it one's going like this way and then the other one's going this way? Like they flip. One's flipped.
What?
Sine and cosine. What's the question again?
What's the difference?
What's the difference when you graph sine and cosine? They are a certain kind of transformation of each other. Yeah?
They're a phase shift apart.
They're phase shifts of each other.
See, we need a river. We need this fine.
We were struggling. We were wrong.
So that's sine,
Oh, I like that.
that's cosine.
Whoa.
Sine and cosine look almost the same.
They're just one off.
It's just one of them is a little bit off.
That's kind of like you.
Well,
we should
since
just like keep doing that.
since secant and cosecant are the cosine flipped and the sine flipped, they're going to look pretty much the same. Secant and cosecant. They're just going to be one off. So you're still going to have the same kind of graph, except look at where the U shapes and N shapes are. They're just pushed one off.
Did you see the face? Just
And yeah, so they look very, very similar because sine and cosine look very, very similar.
Oh, okay.
And this one is cosine flipped and the other one is sine flipped. So that's why they're all just a little bit off. And what do all those green lines represent?
Asymptote.
They're all asymptotes.
Bro, that's
So what I want to write down now is I want to add to that table what are the original asymptotes when you're dealing with secant and cosecant. You've got lots of asymptotes. let's just label this asymptote 1, 2, and 3. This is a full section of cosecant. What's in that box? A full U shape, and then the full N shape. How many asymptotes belong to that box? We've got to be careful because when we draw another box, like right here, we have to be able to have the same number in that box as well.
It looks like 3, but
So if you say all 3 of these belong to this box, then let's label these, I'll just 4 and 5.
so it's only 2.
So if 1, 2, and 3 belong to this box, which 3 belong to this box then?
What? Well,
4, 5,
you didn't. You drew the like.
6.
I don't even know. 4, 5, and that.
Well, 1 already belongs to this box, so we can't say 1. But but according to that, we've got to pick 3 of them.
So is it only 2?
It's only 2.
Yeah.
Can we
4
get
and
like a
5
1 and a
belong
half?
to the one on the left, and 2 and 3 all belong to the one on the right.
Yeah, it's however, it doesn't really matter how you think of it. I mean, 2's in the middle, so that definitely belongs to this box. But the 1 and the 3 are both on the edges. Okay, that's like the armrests again. You can't take both on the edges and put them in the same box. So I usually just think of it as 1 and 2 belong to this box, 3 and 4 would belong to the next box. So there are only 2 asymptotes per box. If you say 3, you're going to get stuck because you can't have 3 per box. It's like taking both armrests. Not everybody can do that. It wouldn't come out equal. Yeah.
So is that box 1 cycle?
Yeah, these box, I didn't draw it perfect, but this box right here, this is 1 cycle. Yep, a U shape and an N shape. And that U shape and N shape just keeps repeating over and over, just like that. Okay. So now when we talk about secant, cosecant, that's why I have 2 asymptotes per box, because there's 2, there's not 1. Okay, so these numbers right here, these are all of the original asymptotes. You don't have to memorize all of them. All you have to know is where you start and then how often they keep repeating. Okay, I didn't really get to the right-hand side right now. That's okay. Okay, so this is the most important part right here. So let's try this one. Find the domain, the range, the period, and the asymptotes. Okay, let's start with the asymptotes because that we can just look up in our chart. Okay. What are the asymptotes of secant? Okay, go to your table. And it says that secant has an asymptote at pi over 2 and 3 pi over 2. Those are the first 2. There's more, but those are the first 2. So let's write them down. So we have one at pi over 2. And what was the other one?
3 pi over 2.
3 pi over 2. Now, if that's all you write, you haven't really listed every asymptote. How many have we listed? We've listed 2. Well, it's impossible to write every single one of them because there's an infinite amount of them. But we don't need to. All we have to do is write down the first 2, and you just have to tell me how often they repeat. Okay? I said that out of the 6 functions we studied, 4 of them have the same period, and 2 of them are different. What's the period for secant and cosecant? And if you get stuck, think of which function it is flipped, and think of the period of that one, and it'll tell you the answer. Yep.
It's 2 pi.
This is 2 pi. Every trig function has a regular cycle length of 2 pi, unless it's tangent or cotangent. That's 1 pi. So how often, if the period is 2 pi, how often is this asymptote going to repeat? Every what? Every 2 pi. It's going to repeat every single cycle. Every single period, you're going to get this asymptote again. So the way you represent multiples of 2 pi is like that. If you have a 1 for n, that means you're adding 1 cycle. If you have a 2, you'd be adding 2 cycles. If that was a 5, you'd be adding 5 cycles. But this represents an infinite amount of asymptotes. And now that was the first one in the box. This was the second one. How often does the second one repeat? Yep, every 2 pi. So you're going to have this asymptote again, 2 pi units later, 4 pi units, 6 pi units, 8 pi. It's just going to keep repeating every cycle. That's how you describe your asymptotes. What about the domain? How would you describe the domain of this? You can't say all real numbers because there's certain values that are not included.
Would you use the n?
Well, what values for x are you not allowed to use in that? Yep.
Pi over 2.
Pi over 2.
Pi over 2.
3 pi over 2. What else?
And all the rest of the asymptotes.
Yeah. So when we describe the domain here, the best we can do is basically say all reals except the ones that would be the asymptotes. All reals except asymptotes. And the range. Does it look like this graph goes up forever?
Yes.
Yes. Each U shape does keep going up forever. Does it look like it goes down forever? It does. Each N shape goes down. Does it hit everything in the middle?
No.
No. There's a gap inside here that never gets hit. What do you think that gap is? Yeah? Yeah, the gap is -1 to 1. That's the gap that we miss.
It's where cosine and sine would have hit.
Right, it's where the sine and the cosine would have been. They would have been in the middle right there, like that. So the range here is everything from 1 and down, -1 and down, and from 1 and up. So it's everything that's not in this gap. And that's how you write it. So everything from -1 and down, or 1 and up. So everything except the gap. This is just a little bit of a look at the other graphs. Again, we don't go into as much depth, and we don't do any graphing by hand. So that covers it pretty good. So we put up this. So there's going to be 10 questions from, this is 6.1 part 3. And then I got to figure out the questions I want from you. All right, so that's the homework. It's the same as normal. It's about 15 questions.
I have one.
It's about what we normally do. I will put the test topics on the board while you guys are at lunch.